PLA for the future also have a very good future.
It's stated to be commercially compostable, correct?
Yeah. We produce the PLA products for medical application. We print it, we wear it.
Hey everybody, we've got a very exciting guest in the Maker Lab at Microcenter today. We've got Dr. Kevin Yang from eSUN Filaments, one of the largest manufacturers of PLA filament in the world, with us today. And we're going to ask him a bunch of questions about the history of filament and the process of making filament.
Thank you for your invitation. I'm very happy to be here.
eSUN's been around for over 20 years, correct?
Yeah, the company set up in 2002, till now more than 20 years already.
In 2002, 3D printing at home was not a big thing yet. It was still very early. So in 2002, what was eSUN producing before they were producing filament?
We are struggling for survival. We do some trading. For example, we sell chemicals, lactic acid, this kind of chemicals, to make money to survive the company. And also at the same time, we do some research and the development of a PLA from polymerization, modification, then find different kind of applications that time.
So in those early days when you were working on coming to PLA filament and 3D printing was just starting up, ABS, I think, was more popular at the very beginning of 3D printing. Did you ever mess with ABS material in early days, or was the goal always to go to PLA?
2006, that year, we got the first inquiry from Europe. One customer asked us to produce the PLA filament. Even that time, we don't know what's it for. Filament for welding rod or for what application, we don't know. Yeah.
Right.
Then we produce some samples and send to our customer. They are very happy. Then continuously we produce more and more for them. And then more and more inquiry mentioned about 3D printing. We thought, maybe it's for 3D printing. Then we research it. Actually it's for 3D printing.
Yeah.
Then we visit the customer to make sure it's ready for 3D printing. That's true. Yeah. Then
that was the case.
That's the case, yeah.
You focused on basically giving a customer what they wanted, and it turned into an entire industry. It turned into, would you say it's your main product? The filament is your main product that eSUN creates?
Yeah, at that time, then we visit customer, and more inquiry ask us to not only provide the PLA filament, also they are looking for ABS or other materials. Then we start to produce ABS filaments also, according to our customers' inquiry, and HIPS and PETG, more and more. Yeah. Not only PLA.
Right.
From PLA, but more and more materials to meet the customers' inquiry.
And I try to remember in my own memory where I was and what was happening in the 3D printing world. I think for me, it was back in 2009 or 10, I start to learn about MakerBot. I start to learn about PrinterBot in consecutive years. And I remember that a lot of times people were printing with ABS. And then it was very clear around 2011, 12, 13, that PLA was going to be the preferred material going forward because of its properties. Very clear at Microcenter, the amount of PLA we sell over any other type of filament it's very clear that that's what the customer wants. In early days, printers didn't have heated beds. So PLA was a good use for that because PLA could print way easier without a heated bed. Printers were not enclosed as often, like DIY printers did not have full enclosures. So all of these things that were kind of needed for ABS, PLA came in and kind of saved the day. PLA Plus, I think, is one of my favorite versions of it, especially the true red PLA Plus I like a lot. PLA Plus is a good mix for projects that a lot of people do.
Yeah, actually, I think that time PLA got into market from the printer and the filament, they help each other. For printers with PLA, no need for heating plate and also champing or something. And then can lower down the cost for the printers. That time you can find the MakeBot and also many DIY printers. No champing, no heating plate or something.
Right.
And also the price down and down.
Right.
More and more customer can buy affordable.
Right.
To buy printers. I think PLA filament promote the printers, low down the price, the cost.
Let's talk about the environmental impact of PLA a little bit. some of the things I do understand is that it's a biopolymer that's generated from renewable resources, correct?
Yeah, PLA, the raw material is from corn, tomato, this kind of plant materials. Yeah, we use the corn, for example, to produce starch, and then produce the sugar, something.
Glucose?
Glucose, yeah, sugar, yeah. Then bacteria inside to produce lactic acid.
Yeah.
Lactic acid, then polymerization to produce the polylactic acid. That's the PLA you can find from the corn starch.
Transformation from the corn to, I think a lot of people understand that maybe before it turns into a monofilament or the filament that we know, it's pellets, it's pelletized, correct?
Yeah, firstly, usually we produce the PLA maybe pelletized for small granules, then do a lot of modification. You know? Yeah, we must put some, for example, pigment colorant additives to improve the property of the raw material.
Right.
This process we call the modification.
Yeah.
For different applications, not only coloring and also chemical property.
Yeah.
Yeah. For example, PLA is very rigid. You print, maybe break.
Yeah.
Yeah. Then we add some additives, for example, modifiers to make it stronger, not so easy to break.
So some other polymer that goes into it.
Yeah.
And then you have something, and my guess is the difference between maybe PLA and PLA Plus. PLA Plus has more of the polymers to make it slightly more malleable. 3D print at home, I prefer to put a PLA Plus because I know that it has kind of those additives that give it a better property that I like for the things that I print. Are you able to tell me roughly how much percentage in maybe something like PLA Plus is like raw virgin PLA versus additives and color?
I think more than, for example, roughly more than 95.
95, okay.
Even more, yeah.
So that's kind of neat because that's a very small percentage of extra stuff going into the PLA, because one of the things that made PLA so popular is not that only it's renewable resources, it's stated to be commercially compostable, correct?
Yeah.
So can you tell me a little bit about what that's like? You can actually take PLA, used PLA, and you can help it break down back into nature, right?
Actually, PLA, is bio-based from the cornstarch, and also PLA is biodegradable materials. And some industry and some conditions, for example, for temperature 60 degrees Celsius and 80% moisture with bacteria and oxygen inside, usually 3 months to 6 months, it will degrade into carbon dioxide and water. It's totally,
wow.
Yeah, it's that we call it's industry compostable.
Yeah.
It's so we need add some additives inside to keep the property, to improve the property. Yeah, and also finally, if after usage, we would like to, for example, waste PLA, we do some recycling. Also, we can do recycle back to monomer. For example, lactic acid, we put the water inside, cool it, then lactic acid we produce. And also we come back to lactide. Yeah, that's recyclable. PLA for the future also have a very good future. It's because it's bio-based, biodegradable, also recyclable. Materials. Yeah.
For all intents and purposes, it's perfectly good material. I know a lot of people when they get into 3D printing, they want to go to more what they call engineering filaments, right? Whether they want to go to ABS, ASA. For me, and I think for a lot of people, 90% of the time, PLA is a great plastic for even doing things that will be used in different things. So I know one of our people here at Microcenter has used PLA to create camera jigs for the video department, and they've even done like camera grips that they were walking around with at CES. So it doesn't have to be thought of as just a prototyping material. I think under a lot of applications, PLA is great, even for the final application.
Yes, not only for prototyping, also PLA after modification. For example, PLA, two main troubles for PLA. One is easy break, another one is thermoforming temperature is low and also high. For example, 60 degrees in the car, and the sun will be the form will change, right? So we usually do modification to improve the property of the toughness. Another one is temperature to improve the temperature resistant. For example, we can do after modification, the heating resistance can improve. For example, maybe more than 100. Now just 60. So if the temperature improved, more and more applications can be.
I agree. I think for me, when I think about PLA, some of my limitations are, am I going to put this in my car? Is this going to live in my car? But if you have a PLA variation that can handle much more, I would rather print with PLA than have to reslice for PETG or reslice for another material. Can I ask you, generally in PLA production, where is the majority of the corn coming from? Is that native to the U.S. or is that somewhere in China it's being grown, or where is the source of the PLA?
That's a very good question. So also for more than 20 years, I visited a lot of places globally. At the beginning, also for eSUN, we would like to produce the PLA raw material. Then after traveling globally, we found, maybe, for example, US is the best place, or maybe Brazil is a very good place, just because in US, corn here, very good. Rich of corn. And also in Brazil, a lot of sugar cane or something, sugars over there. And even Southeast Asia, you can find Thailand, NatureWorks, and also Total Copian, they produce PLA in Thailand. Why? Just because they are not of cassava. This kind of cassava can provide starch. So compare with globally, we make a lot of comparison. We found maybe US, Brazil, Southeast Asia is a good place for corn, for starch. Produce. I
think there's two other things we could talk about, and that's the future. And maybe the first thing we could ask is about uses of PLA that aren't necessarily 3D printing, and where you see that going in the future.
For example, single-use plastics for forks, knives, spoons, or something. But that time we compare with the traditional plastics, the price is high, so the market is not so good. We found 3D printing. I think that's a very good match. We found, that's our direction. Not spoons, knives, that's not our business. Then we transfer to 3D printing, more focused on 3D printing. Then the business better and better from maybe 2010. Each year, raise gradually, very better and better, not only this years, not only for 3D printing, also add more applications for PLA, better and better. For example, for this one single-use plastics products, that's one. Another one is PLA fiber for textile for application,
So in maybe a few years, I would be wearing a shirt made out of PLA.
Now in our company, we have more than 400 people. Each person will have a PLA t-shirt, polo, shirt, trousers, even shoes. We use PLA. Let our people know PLA better, not only for 3D printing, also for other applications. So we have a t-shirt, we print it, we wear it. We have a slogan on the t-shirt.
Oh wow! We print it, we wear it. That's pretty cool. Are there use cases in other industries such as medical or industrial, or do you see like mechanical things that are benefiting from the use of PLA as well?
Also for medical applications, we produce the PLA products for medical application. I say implant inside the body. So we have one section for medical applications. That's one. And the second one is 3D printing. Third one is textile, fiber and textile. The last one is one single-use plastics products for footwear or something like this one.
And the medical thing is interesting because PLA, by its natural properties, is not toxic to humans, correct? So that's what allows you to be able to create things that are maybe implanted or will come in contact with the skin and have no issues over a long period of time.
Stitches. So no need for take away. Then you wear this pill inside your body.
And it will like just disintegrate over time.
Usually PLA inside the body, first step to degradable into lactic acid.
Yeah.
Lactic acid,
Yeah.
we after exercise,
Yeah.
feel sore, that's lactic acid.
Yeah.
So,
That's cool. That's crazy. So next time I get injured and I go to the hospital, they may sew me up with the same material that we're using to 3D print filament. Different, not same, but yeah.
And also now very popular for beauty. Beauty, PLA small particle
Yeah.
injection our body.
Yeah.
The first time just PLA maybe feel you more like inside the body.
Yeah.
And then your muscle will grow and the PLA will disappear. And then you can make yourself better, beautiful. And this kind of beauty. We use this one now, very popular, globally. Just recently, 2 or 3 years, use PLA particles, injection out.
Sort of like tattoo. Like temporary tattoo, maybe.
Not temporary, inside the body.
Right. But it will break down over time still?
Maybe 3 months, 6 months, it will disappear. Then your muscle growing by yourself.
In the future, will there be super PLAs? And what sort of modifications do you see coming for PLA to go with the future of 3D printing?
Just because the 3D printing technology now improved a lot. For example, the printing speed faster and faster. So for the future, PLA not only for the starters for prototyping or this kind of applications, so maybe more and more for industry applications. So one side for the PLA, we must modify it for maybe high heat resistant or maybe harder toughness. More for industry application. That's one trend. Another trend may be more for one thing use, easy degradable.
Yes.
So 2 directions. For example, PLA PHA compound may be easier for compostable,
right?
Degradable. So 2 directions. One is more durable. Another one easy compostable.
Do you have any predictions in 3D printing beyond the filaments? I think the big change we saw in the past year and a half has been speed. I think its reliability continues to improve every year. So speed and reliability, are there any predictions that you have for the 3D printing industry in terms of what technologies we might see in the next 2 to 5 years?
Yeah, that's a very good question. Recent 2 or 3 years, the printing speed improved a lot, maybe several times, right? More productivity. So from maybe consumer market to industry market, more and more. So you can find more and more factories have their own 3D printers. So for the future, next. Also, people are looking for new improvement for 3D printing. For 3D printing, maybe 2 sides. One is high speed. Another one is maybe high, more accurate.
Finer detail.
And then maybe different kind of colors or maybe materials can be mixed together or combination together. Also, that's materials, 3D printing. Also, that's a trend. I don't know, for example, for colorful 3D printing. Now also, that's one. Multiple materials. That's another one.
So I remember maybe early MakerBot days or early Ultimaker days, they would always show off the radio-controlled, the RC car wheels, where they would have a firm interior and then they would have TPU on the outside to make like a better rubber wheel. So mixing materials in the future, you think is a potential. That's interesting. So up until this point, we've basically said, okay, I might print multiple PLA colors, and I've seen many examples of people printing different materials for different reasons. But if you want to print maybe a shoe, you want a more flexible material for the sole, and then a slightly more rigid material up above, and mixing those could be a benefit in the future.
I think a very good case for shoes industry. I think 3D printing will change the whole industry, more like a dental industry.
Yeah.
Now, for dental industry now, more and more 3D printing technology are being used. Yeah, and then I think the next one may be shoes. Yeah. Now we can use 3D printing to print insole and also the whole shoes, also by Adidas or this kind of manufacturers.
One of the interesting things is that we see just through customers coming into microcenter to buy our filament, is that they choose every day so much PLA, so much PLA. Maybe you can give us some of the benefits to PLA and what has made it so popular.
I think nowadays PLA is the most popular filament among the lot of other things. Yeah, just because PLA have some properties. One is many advantages for 3D printing. One is easy printing, very good printability. Yeah, printability. Yeah, that's very important. For PLA, easy printing, melting temperature not so high, and also no less warping, less crack, very good service, smooth service. Yeah. So compared with ABS or others, ABS, PTG, even other materials, very easy printing. Yeah, that's very important. Even for high speed printing, PLA also very good. It can be melted very fast and solid very fast after modification. So for high-speed 3D printing, PLA also is the best one filament. That's why easy printing. That's one. The second one is safety, because for many end users, PLA is very safe. The temperature, melting temperature, are also high. That's one. Second one, the odor. Melt after melting, and the odor not so strong.
Right.
Smells like sweet candy.
It does.
Like
it does.
Without toxic
fumes.
Yeah, that's one. The second one, even for 3D printing at home, you can find compared with ABS. Closed room. Yeah.
Right. Maybe with ABS you print without exhausting it, and over time you gain a headache.
Yeah.
Whereas PLA, you don't worry, you don't get that headache because it's a bioplastic.
Yeah. The second one is safety. The third one is for the future, for the globally sustainable development with these trends. The material must be bio-based, biodegradable, also recyclable. That makes sense for the sustainable society.
Yeah.
I think these three things, and also more maybe based on PLA, you can modify the lot of things to improve the property for different applications. For example, for industry application, also for medical application. Also, that's a very good basic 3D printing materials. Based on that one, you can develop more and more filaments.
So I just want to say thank you. It's been a pleasure talking, and it's been an honor to have you, Dr. Kevin Yang, in our Maker Lab here at Microcenter. Do you have any last parting ideas or parting words for those out there 3D printing? Any advice?
Also, thank you very much. Thank you, Andy. And also, I think for the future, with the 3D printing technology developing more and more material, eSUN will develop for our customers. So I think good luck for our customer of Microcenter, right?
Thank you. Yeah, it's been very nice to meet you. And make sure to stay tuned to Microcenter's YouTube channel for more interviews like this. And we'll see you next time in the Maker Lab at Microcenter.